Some formulae: sin HA sin HB, it is equal to half cos HA plus B minus cos HA minus B. Sin HA cos HB equal to half sin HA plus B plus half sin HA minus B. Third one, cos HA cos HB is equal to half cos HA plus B plus half cos HA minus B. Fourth one, sin HA plus sin HB, which is equal to 2 sin HA plus B by 2 cos HA minus B by 2. Sin HA minus sin HB, which is equal to 2 cos HA plus B by 2 sin HA minus B by 2. Cos HA plus cos HB is equal to 2 cos HA plus B by 2 cos HA minus B by 2. Cos HA minus cos HB equal to 2 sin HA plus B by 2 sin HA minus B by 2. Cos HX is equal to cos IX. Sin HX is equal to minus I sin IX. Tan HX is equal to minus I tan IX. This is relation between hyperbolic and trigonometric function, right? H means hyperbolic function, you know, right? So some problems in hyperbolic function and relation between hyperbolic and trigonometric function. Then cos IX, same one, sin IX, right? I sin HX, right? So that is the reverse one, right? Then 13th one, some formula in integral, definite integral 0 to infinite sin HAX by sin HBX dx is equal to pi by 2b tan pi by a by 2b. Then 14th formula, integral 0 to infinite cos HAX by sin HBX dx is equal to pi by 2b secant pi a by 2b, right? We'll see the problem. Find the Fourier both sine and cos transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x. Let f of x is equal to e power ax plus e power minus ax by e power pi x minus e power minus pi x. That is the equation number 1. First we are going to find Fourier sine transform. We know Fourier sine transform of f of x is formula fs bar of p, which is equal to root 2 divided by pi integral 0 to infinite f of x sin px dx. That is equation number 2. Using 1 and 2, we will get Fourier sine transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x, which is equal to fs bar of p, which is equal to root 2 divided by pi integral 0 to infinite e power ax plus e power minus ax by e power pi x minus e power minus pi x sin px dx. We know sin px, which is equal to e power I px minus e power minus I px by 2i. So we are going to use sin px value in that Fourier sine transformation, right? Therefore Fourier sine transformation of e power ax plus e power minus ax by e power pi x minus e power minus pi x, which is equal to root 2 divided by pi integral 0 to infinite e power ax plus e power minus ax by e power pi x minus e power minus pi x. Instead of sin px, we are going to use e power I px minus e power minus I px by 2i into dx. Now taking that 1 by 2i outside, so it is equal to root 2 divided by pi 1 by 2i integral 0 to infinite. So e power ax plus e power minus ax by e power pi x minus e power minus pi x into e power I px minus e power minus I px dx. That is equal to root 2 divided by pi 1 by 2i integral 0 to infinite. We are going to multiply each and every term. So in numerator there are 2 plus 2, that is 4 terms, right? First e power ax into e power I px. Next e power minus ax into e power I px. Then a minus, right? Minus e power ax into e power minus I px. Then minus e power minus ax into e power minus I px. Denominator e power pi x minus e power minus pi x into dx, which is equal to root 2 divided by pi 1 by 2i integral 0 to infinite. So we are going to group, right? So x, right, first two terms power e power, right, take x is outside because common, right, so e power ax, so first term in the first term e power ax in the numerator, right, e power ax into e power ipx, this can be written as e power ax plus ipx, x is common, take it outside, e power a plus ipx, then the second term in the numerator plus e power minus ax plus ipx, x is common, take it outside and take minus also outside, e power minus a minus ipx, then third term in the numerator minus e power ax minus ipx, so x is common, take it outside, minus e power a minus ipx, then fourth term in the numerator minus e power minus ax minus ipx, so minus x is common, take it outside, so this becomes minus e power minus x a plus ip by e power pi x minus e power minus pi x dx, right. So this is equal to root of 2 by pi 1 by 2i integral 0 to infinite e power a plus ipx into x minus, we are grouping a plus ip power, right, in one term and a minus ip in the e power in another term, right. So first two terms e power a plus ip into x minus e power minus x a plus ip, right. Similarly, taking minus outside, we are grouping a minus ip term e power a minus ipx minus a minus ipx whole divided by e power pi x minus e power minus pi x dx. So that is equal to root 2 by pi 1 by 2i integral 0 to infinite e power a plus ip into x minus e power a plus ip minus x, that minus a plus ip into x by e power pi x minus e power minus pi x. So one term minus next term, we are separating into two terms e power a minus ipx minus e power a minus a minus ipx by e power pi x minus e power minus pi x dx, which is equal to root 2 divided by pi 1 by 2i integral 0 to infinite e power a plus ipx minus e power minus x a plus ip by e power pi x minus e power minus pi x dx. We are separating into two integrals minus root 2 divided by pi 1 by 2i integral 0 to infinite e power a minus ipx minus e power minus a minus ipx by e power pi x minus e power minus pi x dx. We know that e power ax minus e power minus ax is equal to 2 sine h ax hyperbolic function. So using that idea, so you will get the root of 2 divided by pi 1 by 2i integral 0 to infinite. So this is equal to 2 sine h, right. So if in the formula instead of a you are having a plus ip, right. So this is 2 sine h a plus ipx. In the denominator instead of a you are having pi. So that using that formula 2 sine h pi x. Next second term into dx minus root of 2 divided by pi 1 by 2i integral 0 to infinite. So 2 sine h instead of a you are having a minus ip in the numerator, right. So 2 sine h a minus ip x. In the denominator you are having pi, right. So 2 sine h pi x dx. So this is equal to root 2 divided by pi 1 by 2i integral 0 to infinite, 2 and 2 get cancelled in the numerator and denominator. So you will get sine h a plus ipx by sine h pi x dx minus root 2 divided by pi 1 by 2i integral 0 to infinite. Here also the 2 and 2 get cancelled in the numerator and denominator, sine h a minus ipx by sine h pi x dx. So we know the formula from the definite integral 0 to infinite sine h ax by sine h bx dx is equal to pi by 2b tan a pi by 2b. Here we are going to take the first integrand, right. So the first part, the previous step, right, we are having a instead of a you are having a plus ip, then denominator instead of b you are having pi, right? So we are going to use this formula for that. And the second integrand, so second term of the previous step, so you are having in the numerator sin h a minus ipx, so we are taking a which is equal to a minus ip, and the denominator you are having pi, b is equal to pi. So using this formula you will get which is equal to root of 2 divided by pi 1 by 2i. So first term using the formula pi by 2 pi tan a plus ib pi by 2 pi, right, minus pi by 2 pi tan a minus ip pi by 2 pi, right? So that is equal to root 2 divided by pi 1 by, so we are taking 2 outside, right, because in the previous step pi by 2 pi and pi get cancelled, so you will get 1 by 2. Similarly in the second term minus pi by 2 pi and pi get cancelled, so you will get 1 by 2. So 1 by 2 is common, take it outside. Already you are having 1 by 2i, right, outside. So 2 into 2 you will get 1 by 4i into tan a plus ip by 2, right? In tan a plus ip pi by 2 pi and pi get cancelled, so you will get a plus ip by 2 minus second term tan a minus ip, here also pi and pi get cancelled, a minus ip by 2. So that is equal to root 2 divided by pi 1 by 4i. So tan can be written as sin by cos, sin a plus ip by 2 cos a plus ip by 2 minus sin a minus ip by 2 cos a minus ip by 2. So taking LCM, we are going to take LCM. So root of 2 divided by pi 1 by 4i. LCM is cos a plus ip by 2 into cos a minus ip by 2. So we are just cross multiplying sin a plus ip by 2 into cos a minus ip by 2 minus sin a minus ip by 2 into cos a plus ip by 2. That is equation number 3. So we know sin a into cos b is equal to half sin a plus b plus sin a minus b. Here a and cos a sin b. Here we are having, see first in the previous step you are having sin cos minus sin cos, right, sin a cos b. We are going to use that formula in denominator cos a cos b. That is also there, right? Now sin a cos b formula, right, half sin a plus b plus sin a minus b. Second formula is cos a sin b, half sin a plus b minus sin a minus b. And third formula cos a cos b, which is equal to half cos a plus b plus cos a minus b. We are going to use all the three formulas here. So instead of a we are going to take a plus ip by 2 and b is equal to a minus ip by 2. So we will get sin a plus ip by 2 cos a minus ip by 2 from the formula of sin a plus ip by 2 plus a minus ip by 2 plus sin a minus ip by a plus ip by 2 minus a minus ip by 2, which is equal to half. So 2 is common LCM. So a plus ip plus a minus ip, second term plus half sin 2 is the common LCM, a plus ip minus a plus ip, right, which is equal to half. So sin numerator ip minus ip get cancels, 2a by 2, second term plus half sin, here a minus a get cancelled, 2 ip by 2, 2 and 2 get cancelled. So first term which is equal to half sin a plus half second term sin ip. This is equation number A, capital A. Next we are going to use the second formula cos a plus ip by 2 cos a minus ip by 2, cos a cos b formula, half cos a plus ip by 2 plus a minus ip by 2 plus cos a plus ip by 2 minus a minus ip by 2. Similarly taking the LCM, half cos a plus ip plus a minus ip by 2 plus half cos a plus ip minus a plus ip by 2, which is equal to half cos. So numerator plus ip minus ip get cancelled, so 2a by 2 second term plus half a minus a get cancelled, 2ip by 2, that is equal to half cos a plus half cos ip. That is equation number B, capital B. Then third one, cos a plus ip by 2 sin a minus ip by 2, cos a sin b, half sin a plus ip by 2 plus a minus ip by 2 minus half sin a plus ip by 2 minus a minus ip by 2, which is equal to half sin a plus ip plus a minus ip by 2 plus minus half sin a plus ip minus a plus ip by 2, which is equal to half sin. So again ip minus ip get cancelled, 2a by 2. The second term minus half sin a minus a get cancelled, 2ip by 2. That is equal to half sin a minus half sin ip. That is equation C, capital C. So we are going to use equation capital A, capital B and capital C in 3. So Fourier sine transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x is equal to f s bar of p, which is equal to root of 2 divided by pi 1 by 4i. So half sine a, we are using this equation a, b, c, plus half sine ip minus half sine a minus half sine ip divided by half cos a plus half cos ip, that is equal to root 2 divided by pi 1 by 4i, half sine a plus half sine ip, taking that minus inside the bracket, half sine a minus into minus plus half sine ip by half cos a plus half cos ip. It is equal to root 2 divided by pi 1 by 4i. The numerator half sine a minus half sine a get cancelled. So 2 times half sine ip. So 2 by 2 sine ip. Denominator as it is half sine cos a plus half cos ip, which is equal to root 2 divided by pi 1 by 4i. So so taking in the numerator you are having sin ip, 2 and 2 get cancelled. The denominator half is common, 1 by 2 is common. So that is 1 by 2 in the denominator, it will become 2 in the numerator, right? 1 by 2 is 2, right? That is why 2 into sin ip by cos a plus cos ip, which is equal to root 2 divided by pi 1 by 2i sin ip, right? Cos a plus cos ip, because 4 and 2 get cancelled, remaining you are having 2 in the denominator, that is why 1 by 2i. That is equation number 4. We know cos ix is equal to cos hx, sin ix is equal to I sin hx. So we are going to use this relation, trigonometric and hyperbolic relation. So from 4, Fourier sine transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x is equal to fs bar of p, which is equal to root 2 divided by pi 1 by 2i I sin hp, right? So we are using trigonometric hyperbolic relation. So in denominator cos a plus cos ip is cos hp, right? That is equal to root 2 divided by pi I is in the numerator, take it outside, I by 2i sin hp by cos a plus cos hp, I and I get cancelled. So root 2 by pi 1 by 2. So sin hp can be written as sin ax is equal to e power a minus e power minus a by 2. So same idea, instead of a you are having p, e power p minus e power minus p by 2. The denominator cos a. Similarly cos hp is e power a plus e power minus a by 2. Instead of a you are having p, so e power p plus e power minus p by 2, right? We are using this hyperbolic formulas, right, in exponential, right? Relation between hyperbolic and exponential, we are using these ideas right here. So which is equal to 2 and root 2 get cancelled, so you will get root 2 in the denominator, already root pi in the denominator, so 1 by root of 2 pi e power p minus e power minus p by 2. So taking LCM in the denominator, so 2 is the LCM, 2 cos a plus e power p plus e power minus p. So 1 by 2, that is e power p minus e power minus p by 2, say 2 in the denominator, right? Similarly in the denominator you are having 2 in the denominator, so 2 and 2 get cancelled, that is half in the numerator, half in the denominator get cancelled, so remaining 1 by root 2 pi e power p minus e power minus p divided by 2 cos a plus e power p plus e power minus p. Therefore, Fourier sine transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x equal to f s bar of p, which is equal to 1 by root 2 pi e power p minus e power minus p 2 cos a plus e power p plus e power minus p. So next we are going to find Fourier cos transform of e power ax plus e power minus ax by e power pi x minus e power minus pi x. We will see in the next video. Because of the length of the video, I am splitting into two videos. So next video we will see Fourier cos transform. Right? Thanks.